Good morning. Good morning, all. Welcome to a new topic for the AFCAT exam preparation. Our topic is time, speed, and distance. Time, speed, and distance. This is our topic. We know that the basic relation between time, speed, and distance. Distance is equal to speed into time. Distance we will represent in kilometer. Speed we have to represent in kilometer per hour, and time we have to represent in hour. Then only we will be able to match the units. If distance is in kilometer, speed should be in kilometer per hour and time should be in hour. If we are representing distance in meter, the speed should be given in meter per second and the time should be in second. So unit should be matched before doing the calculation. Here distance can be x kilometer and here distance can be x meter. Like that you can keep the unit. So when you are saying kilometer, speed should be in kilometer per hour and time should be in hour. If you are using distance in meter, then speed should be in meter per second and time should be in second. Then average speed. What is average speed? Average speed is actually equal to total distance covered by a body. Covered by a body divided by the total time taken. Total time taken. That is denoted as average speed. We will consider two cases of average speed. Here, first case is when time remains constant. When time remains constant and speed varies. When time remains constant and speed varies. For example, if a man travels at a rate of x kilometer per hour, x kilometer per hour, kmph means kilometer per hour. That is the speed of a person who is traveling at a speed of x kilometer per hour for t hours. Time is t hours. After that, he again goes with a speed of y kilometer per hour for another t hours. So first he is going with a velocity of x kilometer per hour for a time of t, and after that he continues traveling with a different speed y kilometer for another t hours. Then for the total journey, what is the average speed? What is average speed? total distance covered by a body by total time taken. This is this formula for average speed. Total distance covered by a body by total time taken. So total distance, for example, when a person is traveling with a speed of x for a time t, the distance, so we can consider like this. This is point A, this is point B, and this is point C. From A to B, he is moving with a velocity of x kilometer per hour and time taken is t. From B to C, we don't know what is the distance between A and B and B and C, but the velocity we know y kilometer per hour, the time t is same. Here the time is same. So what is the distance traveled from A to B? Distance can be written as d1 equal to speed into time, means x into t. So that is the distance between A and B. The distance between B and C is d2 equal to y into t. That is also distance is equal to speed into time. So what is the formula for average speed? Total distance covered by a body by total time taken. So total distance will be d1 plus d2 and the total time is t plus t. So total is average speed equal to total distance. Total distance by total time taken. Total distance can be written as d1 plus d2 total time for A to B and B to C. The time taken is common, so the total time is t plus t, so t plus t. So d1 can be written as x into t and d2 can be represented as y into t divided by 2t. So you can take t common from the numerator. So x plus y into t divided by 2 into t. Here you can cut t cut. So you are getting x plus y by 2 kilometer per hour. So that is the average speed. So this is the case 1. If when time remains constant but speed varies. So what is the average speed? So this will be the formula. Average speed is equal to x plus y by 2 kilometer per hour. Condition. What is the condition? When time remains constant. If a person is traveling from A to B and B to C, from A to B, the time taken is t, and from B to C, the time taken is t. Both time are equal, but in both area he is going with a different velocity. So what is the average velocity? That is x plus y by 2. Then the second case is the distance covered is same. Distance covered is same, but speed is different. Speed is different. Initially time is constant and speed and distance is different. Here distance is a constant and time and speed is different. So for example, A to B and B to C. This is d distance and this is also d distance. The velocity from A to B is x kilometer per hour. The velocity from B to C is y kilometer per hour. So average speed, what is the formula for average speed? Total distance traveled by total time taken. Total distance traveled by total time taken. So total distance, you can see that d plus d, that is the total distance. So total time, so when a person is traveling a distance d with x kilometer per hour, the time taken t1 can be represented as distance divided by speed. So d by x. Similarly, the time t2 is the distance divided by the speed. So the time taken to move from A to B is t1 and time taken from B to C is t2. Here the distance is common, but velocity is or the speed is different. So distance by speed is the formula for time. Therefore, t1 equal to d by x and t2 equal to d by y. So total distance is d plus d. So total time is t1 plus t2. So numerator 2d, denominator instead of t1 you can put d by x, instead of t2 you can put d by y. So you can take d common, so you will get 1 by x plus 1 by y. This d get cut, so 2 by 1 by x plus 1 by y. This is average speed. 2 by 1 by x plus 1 by y. That is average speed. This can be solved if we calculate the LCM of the denominator part. The final answer will be 2xy by x plus y, average speed. So here we discussed the two cases. In first case, time from A to, from if the person is moving from A to B and from B to C, the time is constant. From A to B, the time taken, and from B to C, time taken is constant. But distance and speed is different. So here the average velocity is x plus y by 2. When the distance if we are keeping constant and the time and speed is changed, there the average speed is 2xy by x plus y. So that is the formula for average speed. You should not take average if somebody is moving with a velocity 3 kilometer per hour and some other distance 4 kilometer per hour. Without looking to the condition, you should not put 3 plus 4 by 2. It is completely wrong. You have to use the correct concept. You have to use the correct concept. Simply putting the average of the two different speed is wrong. You will not get the average speed. So correct formula you have to use. If the time taken is same for two different distance, the average speed is x plus y by 2. If the distance here, time is constant. Time is constant. Second case, average speed. Here 2xy by x plus y, either here distance is constant. That is very important. If the time is constant, x plus y by 2. If the distance is constant, 2xy by x plus y. That should be the formula. Then relative speed. Then the concept of relative speed. So relative speed, here we have to consider two bodies. Two bodies are simultaneously moving. That case we have to consider. For example, body is moving from A and the another body is B. Both are moving in the same direction. Both are moving in the same direction. Either the direction is same. The movement of direction is same direction. But A is moving with a velocity of V1 and B is moving with a velocity of V2. Then the relative speed can be written as relative speed. Since both are moving in the same direction, if we want to calculate the relative speed, we should add both the velocities. V are equal to V1 plus V2. So what is the condition? Condition is the both the bodies are moving in the same direction. The second case, a body is moving in a forward direction, another body is moving in the reverse direction. The speed of the body 1 is V1 and the speed of the body 2, that is B, is V2. Both are moving but opposite in direction. Opposite in direction. Movement is opposite in direction. Here the relative speed can be represented as V1 minus V2. You should consider the magnitude because sometime, for example, V1 moving with a velocity of 18 kilometer per hour and V2 is moving with a velocity of 25 kilometer per hour. So relative speed is equal to V1 minus V2 means 18 minus 25, that is minus 7. You cannot say that a body is moving at a velocity of minus 7 kilometers. That is meaningless. So we have to consider the magnitude. So finally you will get only consider the magnitude of the. So if, even though it is V1 or V1 minus V2 or V2 minus V1, the velocity should not be negative. So we have to consider the magnitude only.
18 kilometer and 25 kilometer is the given or used?
So just as an example, a body is moving with a forward direction with 18 kilometer and the another body is moving with a reverse direction with 25 kilometer per hour. So the relative velocity can be considered as the difference between two. But difference can be minus also. If you are taking 18 minus 25, it will be minus 7. So you should not put minus 7. You have to consider the magnitude only. We will do some example. The speed of two trains. We'll see what is this question. The speed of two trains, one moving at the speed of 80 kilometer per hour and the other at 10 meter per second. You have to calculate the ratio of their velocity. That is a simple question, not connected to relative velocity. One train is moving with a velocity of 80 kilometer per hour. Another train is moving with a velocity of 10 meter per second. So you have to calculate the ratio of their speed. This is V1, this is V2. You have to calculate V1 by V2. Here you have to see the unit because you cannot put 80 by 10. That is wrong because 80 is given in kilometer per hour and 10 is given in meter per second. So how to convert kilometer per hour into meter per second? That is 80 kilometer per hour. 1 kilometer is how much? 1000 meter. 1 hour is 60 into 60 into 60 into 60 seconds. Because 1 hour is 60 minutes, 1 minute is 60 seconds. So 60 into 60, 3600. That is normally as a you can represent like this 1000 meter divided by 60 into 6. 60 into 60 seconds. So this you are getting 10 by 36. So 5 into 2 and 18 into 2. So if you want to convert kilometer per hour into meter per second, you have to multiply with 5 by 18. If you want to convert kilometer per hour into meter per second, you have to multiply with 5 by 18. So kilometer per hour is converted into meter per second by multiplying with 5 by 18. Similarly, if you want to convert meter per second into kilometer per hour, you have to multiply with 18 by 5. Because here 80 kilometer per hour, 80 kilometer per hour, that is converted into 80 into kilometer 1000 meter. 1 kilometer 1000 meter. 1 hour is 60 into 60 second. This is actually 80 into 5 by 18 meter per second. Because 1000 by 660, 5 by 18. So what you will get? 40 into 2, 9 into 2. So you cannot divide. So 200 divided by 9. So that is one of the velocity. That is V1 is equal to 200 by 9 meter per second. What is V2? V2 is given as 10 meter per second. V2 is 10 meter per second. So what is the ratio? V1 by V2 equal to 200 by 9 meter per second divided by 10 meter per second. Now you can see that both units are same. Both units are same. So it will be 200 divided by 9 into 10. So this 0 got cancelled. So 20 is to 9 will be the answer. 20 is to 9. That is the ratio between two speeds. So answer is correct. 20 is to 9. So you have to check whether the both units are same. 80 kilometer per hour. That is V1. V2 is 10 meter per second. So if you want to divide two quantities, the unit should be same. So 80 kilometer. Kilometer is equal to 1 kilometer is equal to 1000 meter. 1 hour is equal to 1 hour is 60 minute. 60 minute means 1 minute is 60 seconds. So 1 hour is equal to 3600 seconds. So here instead of 1 hour, you have to put 3600 seconds. So you can see the unit is meter per second. Here also meter per second. Both are same. Then only you can divide. The quantity should be in the same unit. Then only we will be able to solve. So here this 30 is cut. No need of 30. 20 cut. This 20 cut. Then 10 can be written as 5 into 2 and 36 can be written as 18 into 2. So finally you are actually multiply. Even though you are multiplying with 1000 by 3600, you need to multiply only with 80 by 80 into 5 by 80. That is enough because that is equivalent to 1000 by 3600. That is meter per second. Similarly, if you want to convert, we will do that also. We will put V1 equal to 80 kilometer per hour. V2 is equal to 10 meter per second. Now we will convert back into kilometer per hour. So what you have to do in kilometer per hour, when you are converting into meter per second, you have to use 5 by 18. If you want to convert meter per second into kilometer per hour, you have to use 18 by 5. So this can be written as, so how it is came, 10 meter means 10 raised to minus 3 kilometer. Seconds means like this. 1 hour is equal to 60 minute equal to 60 into 60 seconds. So 1 hour is equal to 3600 seconds. So 1 second is equivalent to, here 1 second, 3000 second means 3600 into 1 second. So 1 second you can write it as 1 hour divided by 3600. 3600. 1 second is equal to 1 by 3600 hour. So here instead of second I will put 1 by 3600 hour. 1 kilometer is equal to 1000 meter. So 1 meter can be represented as 1 by 1 kilometer divided by 1000 equal to 1 meter. Understood? 1 kilometer equal to 1000 meter. You can take this 1000 to the denominator part. So it will be coming here. 1 kilometer by 1000. Remaining is 1 meter. So instead of 1 meter, I am putting 1 hour. 1 kilometer by 1000 means 10 raised to minus 3. If actually 1 kilometer by 1000 means 1 kilometer by 10 raised to 3 equal to 1 meter. So 10 raised to 3, when you are taking to the numerator, it will become 10 raised to minus 3. 10 raised to minus 3 kilometer is actually 1 meter, and 1 by 3600 hour is 1 second. So if we are dividing 10 raised to minus 3 kilometer by 1 by 3600 hour, it is actually coming like this. This 10 raised to minus 3 will be coming to denominator, and 3600 will be coming to numerator. That is equal to kilometer per hour. So 3600, 10 raised to 3 can be written as 1000. So again it is get cancelled. 18 into 2 and 5 into 2. Finally you are getting 18 by 5. So if you want to convert kilometer per hour to meter per second, multiply by 5 by 18. If we come to convert meter per second into kilometer per hour, multiply by, is reciprocal, 18 by 5. So this should be remembered. So V1 equal to 80 kilometer per hour, V2 equal to 10 meter per second. So 10 meter per second can be converted by 18 by 5 kilometer per hour. So 1 into 5, 2 into 5, 2 into 18, 36 kilometer per hour. So what is the speed? What is the ratio? V1 by V2 equal to 80 by 36. 80 by 36 means 20 into 4 is 80, 9 into 4 is 36. Still you are getting 20 is to 9. Understood? So if you are putting in kilometer per hour, no problem. If you are putting in meter per second, that is also no problem. So little bit calculation will be easy if you are converting kilometer per hour into meter per second. Because here also we got 20 is to 9. So here calculation will be little bit easy, because we no need to worry about smaller quantities. So better to convert kilometer per hour into meter per second. So in both cases, anyway, we are getting the same answer, 20 is to 9, and here also 20 is to 9. So consider this is, if you want to convert kilometer per hour into meter per second, multiply by 5 by 18. If you want to convert meter per second into kilometer per hour, multiply with 18 by 5. Next question. An athlete takes as much time in running 12 meters as car takes in cover 24 meters. The ratio of the speed of the athlete and car. An athlete takes as much time in running 12 meters as a car takes in covering 24 meters. Here one athlete is there, one car is there. An athlete is going 12 meter. A car is moving 24 meter. An athlete takes as much time in running 12 meters as a car takes in covering 24 meters. The meaning is the time is constant. For example, the time taken is t. Here also time taken is t. The ratio of the speed of the athlete and car. What is speed? Speed, distance by time. Here the distance is 12 meter, time is t. Here the speed is distance by time, 24 meter divided by t. So speed, that is v1, this is v2. So we need to calculate the ratio. So v1 by v2 equal to 12 by t divided by 24 by t. So you can take the reciprocal and multiply 12 by t into t by 24. So t cut 1 into 12, 2 into 12. So answer will be 1 is to 2. The question is, athlete is moving 12 meter in a particular time. With the same time, a car is also moving, but the car traces a distance of 24 meter. Both the case time is constant. So what is the ratio of their speed? So speed is distance by time, 12 by t, here 24 by t. So v1 by v2 is 12 by t by 24 by t. You will be getting 1 is to 2. Next question. A train passes through a telegraph post in 9 seconds with a speed of 54 km per hour. The length of the train. Here one telegraph post is there. Here a telegraph post is there. A train is here. A train is here. The train passes the post in 9 seconds. If the train passes the telegraph post, means the complete body of the train should pass the telegraph post. But meaning after some time the train should be here. Train should be here. That means the distance traveled by the train is equal to the length of the train. Distance traveled by the train is equal to the length of the train. So distance is equal to length of the train. Distance traveled is equal to the length of the train. What is the speed of train? It is given as 54 kilometer per hour. kmph means kilometer per hour. How much time it is took? 9 seconds. So what is the length of the train? Distance is equal to velocity or speed into time. Velocity is 54 kilometer per hour. So the answer here given is meter. So first of all, you have to convert into meter per second. So 54 kilometer per hour means how much meter per second? We have to multiply with 5 by 18. Mean, if you are getting any confusion, immediately you have to put 1000 meter by 3600 second. So you are getting cut 5 into 2, 18 into 2. So you are multiplying with 5 by 80. So 54 into 5 by 18. 1 into 18, 3 into 18. 3 into 18 is 54. So you are getting 3 into 5, 15. 15 meter per second. 1 into 18 and 3 into 18. So you are getting 3 into 15 meter per second. Velocity 15 meter per second into time is 9 seconds. If the units are same only, you will be able to cut the second and second. So will be remaining will only meter. So 9 into 15, 9 into 5, 45 plus remaining 4, 9 plus 4 is 13, 135 meter. So the answer is 135 meter. That is the length of the train. The concept is if the train passes a post, then the entire length of the train should cover. Then only we can say that the train pass, actually it is gone through the complete telegraph post. So entire length of the train we should consider. So one concept we said in a wrong way. So here the concept is said in a wrong way. Sorry. Here it is relative speed. This it should be in opposite direction. Should be in opposite direction, and this should be in same direction. Opposite direction means that is opposite direction. 1 minute. Opposite direction. Actually, relative speed, the same direction we have to consider. Here it is same direction. Oh, this formula written is wrong. Okay, so opposite direction. Minute. Same direction. Hmm. Same direction we have to consider with a velocity v1 minus v2. Sorry, v1 minus v2, and opposite direction we have to put v1 plus v2. Sorry, relative speed, because the concept is if both are moving in the same direction, if both are moving in the same direction, so the first body will feel relatively small velocity for the second body because both are moving in the same direction. So the concept is V1 minus V2. In opposite direction means, you can see here, if a body is moving with a velocity V1 and the other body is moving with a velocity of V2, so they are moving in a faster mode, because both are in the opposite, means they are moving away from each other. Here one body is moving with a velocity V1, other body is moving with a velocity of V2. So they are moving from each other in a very, very fast mode. Means the velocity we have to consider it as V1 plus V2. If the body is moving in the same direction, both are on the same pitch. Both are on the same pitch. So you have to consider, because one, if a man sitting on the first body and if a man, somebody is sitting on the second body, since both are moving in the same direction, both will be the person sitting on the other body will feel that the other body is moving at a very little velocity, because they are both are moving in the same direction. Therefore they will feel a relatively small velocity. That concept you have to clear. When the both bodies are moving in the same direction, the relative velocity should be V1 minus V2. When the both bodies are moving in the opposite direction, you have to consider the relative velocity is equal to V1 plus V2. Because if two person is moving in the opposite direction, they are moving apart in a very quick manner. If the two person is moving in the same direction, they will not be separated as much as compared to the last case, because both are in the same direction. So they will feel, when the person sitting on the first body looking into the person sitting on the other body, they will feel that both are nearby only. So we can say that the relative velocity is in opposite direction should be plus and the same direction should be minus. Concept clear? Should not confuse. If the two bodies are moving in the same direction, relative velocity should be V1 minus V2. When the two bodies are moving in the opposite direction, velocity should be V1 plus V2, because they are moving away from each other in a quick manner. In the second case, in first case, both are moving in the same direction. They are not separating in a quick manner. Therefore, the velocity should be considered as less, and in opposite direction, the velocity should be considered as in the magnitude of the velocity should be considered in a more as a sum of the two velocities. Clear? Then next question we will do. Two trains starts from a place moving with 45 km per hour and 75 km respectively in the opposite direction. Two trains start from a place. The place is same. For example, this is the place. First train is moving in this direction with a velocity of 45 km per hour. The other train is moving in the opposite direction with a velocity of 75 km per hour. After how many hours they will be 1280 km apart? Meaning, this is the train and this is the initial position. After some time, this train will be this position. So this distance is 1280 km apart. So the question here is, the train is moving from a common place, but they are moving in opposite direction. One with a velocity of 45 km per hour and the other with a 75 km per hour. So since the both trains are moving in the opposite direction, they are moving away from each other in a quick mode. So the velocity, relative velocity, you have to consider as V are equal to V1 plus V2. V1 plus V2. So what is the relative velocity? One is 45 kilometer per hour. The other is 75 kilometer per hour. So total will be 5 plus 5, 10, 7 plus 5, 12, 120 kilometer per hour. Since both are moving in the opposite direction, they are moving away from each other in a very quick manner. So we have to consider the relative velocity as a sum of the individual velocity. So VR should be equal to V1 plus V2. Therefore, VR is equal to 45 plus 75, 120 kilometer per hour. What is the distance? 1280 kilometer. So time taken to get a separation of 1280 kilometer is distance traveled divided by the relative velocity. Distance traveled is 1280 kilometer. Here relative velocity is 120 kilometer per hour. You can see kilometer both are same unit. Kilometer cut, then kilometer per hour. This hour will be coming to the top side. So this zero cut. 6 into 2, 6 into 2, 4 into 2, then 3 into 2, 3 into 2, and 2 into 2. So 32 by 3. 32 by 3 hours. 32 by 3 hours. So 32 by 3 means 10 into 3, 30. 2. So this can be written as 10 and 2 by 3. In a mixed fraction, you have to write 10 and 2 by 3. Understood? So here you have to consider the relative velocity, very important. Don't confuse. When the two bodies are moving in opposite direction, they are actually moving away from each other in a very quick manner. That means we should consider the velocity is very high. If we want to get the velocity very high, we should add two individual velocity. Therefore, the relative velocity is V1 plus V2. So 45 plus 75, 120 kilometer per hour. And the distance between the two train is 1280 kilometer. So distance divided by time, you will be getting 1280 divided by 120 kilometer hour. You are getting in the hour. So here the answer is given in mixed fraction. So you have to convert 32 by 3 into mixed fraction. So 32 by 3 is 10 into 3 and remainder is 2. So you have to put 10 here, the quotient here, and the remainder and divisor. So quotient kya hai? 10. Remainder is 2. Divisor is 3. So you have to write 10 2 by 3 hours. That is the answer. Then next question. If a man can walk to a place in 3 by 4 hours at 3 1 by 4 kilometer per hour, how long would it take another man walking at 3 1 by 6 kilometer per hour to walk there and come back? The question is, a man moving from here to here, A to B. Time taken is 3 by 4 hours. What is the speed? 3 1 by 4 kilometer per hour. So this is case of first person. So man 1. So here you have to convert this into proper mode. That means 4 into 4, 16. 16 plus 3, 19. 19 by 4 hours. This mixed fraction should be converted into normal simple fraction. That is 4 into 4, 16 plus 3, 19 by 4 hour. The speed 4 into 3, 12 plus 1, 13 by 4 kilometer per hour. So what is the distance? Distance is equal to speed into time. So you should know the how to convert a mixed fraction into a simple fraction. If remaining everything is simple, that concept you should have. How to convert a mixed fraction into a normal simple fraction. So 4 into 4, just to multiply 4 into 4, 4 into 4, 16, plus 3, 19, 19 by 4. Here, 3 into 4, 12, plus 1, 13, 13 by 4. So speed is 13 by 4 kilometer per hour. Time is 19 by 4 hour. You can see hour get cancelled. So 13 into 19 by 4 into 4, 16 kilometer. This is the distance between A and B. 13 into 19 by 4 into 4, 16. The question given is the same distance is traveled by some other person. The velocity of man 2, is 3 1 by 6 kilometer per hour. But time is not given. So, but from the first condition, we calculated the distance. So time T2 can be calculated here. So for man M2, the velocity is V2. The velocity of the speed is V2 equal to 3 1 by 6 kilometer per hour. But we have to calculate the time taken by the second person to travel the same distance. So V2 3, V2 is 3 and 1 by 6 kilometer per hour. How to convert? 6 into 3, 18. 18 plus 1, 19. 19 by 6 kilometer per hour. So distance is equal to speed into time. So distance is same. Speed is V2. Time is T2. So T2 can be written as D by V2. D is actually 13 into 19 by 16 kilometer. V2 is 19 by 6 kilometer per hour. So why I keep the without multiplying the value? Because normally in this type of problem, the second will be there will be some proper cutting will be there. So simply wasting our time in multiplication we can do. Keep simply as such, then put it in the second condition. So here 19, 19 and this 19 get cut. So this kilometer cut means hour will be coming to top. So 13 by 16 into 6. 13 by 16 into 6. So 3 into 2, 6. 8 into 2, 16. So 13 into 3 is 39 by 8. 39 by 8 hours. Here the answer given is in mixed fraction. So you have to divide 39 by 8. 4 into 8, 32. So how can write? Quotient, remainder, divisor. Quotient is 4. Remainder is 7. Divisor is 8. So answer will be 4 7 by 8. But the question is given is how long would it take another man walking at 3 1 by 6 kilometer to walk there and come back? So this is for the second person to travel the same distance. If we want to come back means the same time we have to add. So instead of 39 by 8, we have to take one more 39 by 8. Because the second person should go from here to B then he should come back to the same place. That means double time you have to consider. So 39 by 8 is equal to 2 into 39 by 8. So 1 into 2, 4 into 2. So total time taken by the second person to go and come back is 39 by hours. So this can be written as 39 by 4 is equal to 9 into 4, 36. Remaining 3. So this can be written as quotient, remainder, divisor. 9 3 by 4 hours. 9 3 by 4 hours. So the answer will be 9 3 by 4 hours. So we have to read the question properly because they simply put one sentence, how much time he will take to go there and come back. They didn't ask how much time the second person will take to go from A to B. Instead of that, they are asking how much time he will take to go and come back. So we have to add both the answers, both the time, going time and coming time. Since both are same, double of the single time. Then another question: a train 110 meter long takes 3 seconds to pass a man. A person is here. The train will take a person is here. The train will take 3 seconds to pass a man. Means the train will be coming with here by taking 3 seconds. So how long is the platform if it passes through it in 15 seconds moving with the same speed? So here only man is there. So if the train want to pass the man, no need to bother about the platform. So here normally this formula we can use, distance is equal to speed into time. Here the distance is 110 meter. Speed we don't know. Speed into time is 9. How much? It is given as 3 seconds. Okay, 3 seconds. So it should be 3 seconds. So a train crosses a man with 3 seconds. The length of the train is 110 meter. So what is the speed? Speed can be represented as 110 meter by 3. So meter per second, 110 by 3 meter per second will be the speed of the train. Now the question is, how long is the platform if it passes through it in 15 seconds? Here you can see one platform. One platform is here. The train should move from here to here. The total distance the train should travel is equal to the length of the platform plus length of the train. This is the length of the platform, L2. The length of the train is L1. If the train is moving L2 distance, the train will reach only here, only this much point. 1 minute. If the train is moving a distance of L2, it will reach here only. If the train crosses the platform, means the length of the train also should cover. So we have to consider the total distance as equal to length of the train plus length of the platform. Then because train is not a single post, it is actually a big body. So the entire body of the train also should pass. Then only we can say that the train is cross over the platform. So we have to consider both the length of the platform and length of the train. In normal case, here if a man is sitting, we are not considering any distance for the man because man is a thin person, so no need to consider the width of the man. But platform is not like that. If a train is crossing a post or a man, we have to consider only the distance of the only the length of the train as the distance. But when a train is passing a platform with the entire its body, first of all it should cover a distance of the platform. After that, the distance of the train, that much distance also it should cross with an extra effort. So total distance is L1 plus L2. That point is very important. So this L1 plus L2 is covered with a time of 15 seconds. So you can see distance is equal to speed into time. Speed we are not changing. Our speed is actually 110 by 3 meter per second. So distance is L1 plus L2 equal to speed into time is actually 15 seconds. So what is speed? L1 is we can take as 110 meter. L2 is the length of the platform. Speed is 110 meter per 110 by 3 meter per second into 15 seconds. Because already we got the speed as 110 by 3. So second get cancelled. So we'll be getting meter. So 110 plus L2 equal to 110 by 3 into 15. 1 into 3, 5 into 3, 15. So 5 into 110 is 5055. So 110 plus L2 is equal to 550 meter. So L2 equal to 550 meter minus 110 meter. So it will be 0. 4 into 1, 4 plus 1, 5, 4 plus 1, 5. So 440 meter. That is L2. That is the length of the platform. So this is an important question. In two ways they will ask. First, they will say that a post is more crossed by a train in so many seconds. In that case, the distance traveled by the train should be considered as the equal to the length of the train. The second case, they will say that a platform is covered by or a bridge is covered by a bridge is covered by a train in so many seconds. In that case, you have to consider the total distance covered by the train is length of the train plus length of the platform, or the length of the train plus length of the bridge. Yes, you have to, in the same way you have to take. So answer is 440 meter. So answer is correct. Then next question. A man walked a certain distance. A man walked a certain distance. One third he walked at 5 kilometer per hour. Another one third at 4 kilometer per hour. And the rest at 6 kilometer per hour. His average speed you have to calculate. The question is, a person is going from A to B, C, D. A to D. One third means 1 by third. 1 by third is at B and another 1 by third is at C. So we are dividing the total distance into 3 parts: 1 by third, 1 by third, and 1 by third. 1/3 distance with 5 kilometer per hour. Another 1/3 with 4 kilometer per hour, and the rest with 6 kilometer per hour. 1/3 is okay. 1/3, 1/3, 1/3. So remaining 1/3 is also with 6 kilometer per hour. So here the distance is same. D, D, D. So average speed, you have to calculate the average speed. Average speed, the basic formula is total distance covered by total time taken. Total distance covered by total time taken. Total distance. What is total distance? D plus D plus D. So what is total time taken? Time is actually distance by speed, because distance is equal to speed into time. So time is distance by speed. Initially, what is T1 can be written as D by 5. T2 can be written as D by 4. And T3 can be written as D by 6. Understood? So initially the time taken is, you can write like this: T1 plus T2 plus T3. So this is 3D divided by T1 is actually D distance with 5 kilometer, and D distance with 4 kilometer, and D distance with 6 kilometer. So 3D divided by D common. So 1 by 5 plus 1 by 4 plus 1 by 6. So D cut. So 3 by 1 by 5 plus 1 by 4 plus 1 by 6. Okay. So if you are solving this, we will get the answer. So what is the answer? 3 by 120. So 5 into 5, 4, 6. 5, 4, 6 means the LCM can be put as 120. So 5 into 24 plus 30 plus 20. So when you are putting on 5, you have to multiply 6 into 4. 6 into 4, 24. When you are taking the consideration 1 by 4, you have to multiply 6 into 5, 30. Then when you are considering 1 by 6, you have to put 120 divided by 6 into 5 into 4. 6 into 5, 30 into 4, 120. So this can be written as 3 into 120 divided by 5 into 4, 20, 6 into 5, 30. So 30 plus 20, 50, 50 plus 24, 74. So 6 into 60 into 2, 30, 37. So you have to do it. 3 into 60 is 180. 180 by 37. 180 by 37. How much? 4. 4 into 7, 28. Remaining 2, 148. 30 is 32. So remainder is 32. Quotient is 4. Divisor is 37. So answer you can write like this: 4, 32, 37. 4 and 32 by 37. The answer is written in a mixer fraction. So you have to convert anyway into, based on the option you have to convert. 4 and 32 by 37. That is the answer. So normally, if at A to B, B to C, C to D, D to E, like that, if the distance is same, here the velocity is X, here the velocity is Y, here the velocity is Z, here the velocity is, for example, X, Y, Z, W, X, Y, Z. So average velocity can be written. How many distances? How many parts? 1, 2, 3, 4. This can be written as 4 divided by 1 by W plus 1 by X plus 1 by Y plus 1 by Z. If two distances are there, you have to put 2 by 1 by X plus 1 by Y. If three distances are there, you can put 3 by 1 by X plus 1 by Y plus 1 by Z. That is the general formula. Here we have three distances, therefore we are taking 3 by 1 by 5, 1 by 4, 1 by 6. So answer will be 432 by 37. So this general approach you can use for calculating the average speed. If four equal distances are traveled with w, x, y, z, four different velocity, the average speed can be represented by 4 divided by 1 by w, 1 by x, 1 by 1, 1 by y, 1 by z. If two distances are traveled, if uh, two same distance are traveled with two different velocity, then you can put average speed is equal to 2 by 1 by x plus 1 by y. If three equal distances are traveled with three different velocity, then average speed can be represented as 3 by 1 by x plus 1 by y plus 1 by z. So this is another question. Question number 8. A train set off at 2 p.m. at the speed of 70 kilometer per hour. Another train start at 3:30 p.m. in the same direction at the rate of 85 kilometer per hour. At what time the trains will meet? The question is, a train is moving from A. The first train moving started moving at 2 p.m. Velocity is 70 kilometer per hour. Another train started the same point at a time t2 equal to 3:30 p.m. Here the relative velocity concept will not come because both are starting at a different timing. So relative velocity, no need to use the relative velocity concept. A train is started at 2 o'clock and some other train is started at 3:30 p.m. The first train is going with a velocity of 70 kilometer per hour and the second train is moving with a velocity of 85 kilometer per hour. So after anyway, since the first train is going with a slow speed and the second train is going with a higher speed, even though the second train started after a delay of 1.5 hour, since it is moving with a more velocity, at some point it will reach, both will meet together. So for example, if they are both are meeting at a point B, if both are meeting at a point B, so the distance traveled by both are same, then only they can meet together. So the distance in the first case is after some time, right? That what time train will meet. The distance traveled by is equal to v1 into time taken by is t1. So first velocity into the time taken by the first train. So if they are meeting at a some point, the difference in time taken by the first train and second train can be considered as 1.5 hours because there is a delay of 2 hours. 1.5 because once first train started by 2 o'clock and the second train started by 3:30 p.m. So distance is equal to v1 into t1. Here v1 is 70 kilometer per hour and the time is t1. The second case that both the train is traveled the same distance, then only they can meet each other. So d equal to v2 into t2. So v2 is equal to 80. It is not 80, it is given as 85 kilometer. So 85 kilometers. So we will 85 kilometer per hour into T2. Both are same because if we want to meet each other, the distance traveled by both the trains should be equal. So this can be equated 70 kilometer per hour into T1 is equal to 85 kilometer per hour into T2. But the relation, what is the relation between T1 and T2? Very important. What is the relation between T1 and T2? A train is started at 2 o'clock, the other train is started at 3:30 p.m. So the difference between the time taken by the first train is T1. So, and the time taken by the second train is T2. So automatically the time taken by the first train will be more because it is started well in advance and the second train is T2. So T1 minus T2 should be equal to 1.5 hours because 2 and means 3:30 p.m. minus 2 o'clock. So it will be 1.5 hours. So here you are getting two equations. T1 minus T2 equal to 1.5 hours and 70 into T1 equal to 85 into T2. Then we will solve 70 into T1 equal to 85 into T2. So how many? 1 into 5, 4 into 5. 1 into 1, 5, 3, 7 into 5. So T1 equal to 17 T2 by 14. You can write like this. 14 T1 equal to 14 T1 equal to 17 T2. So T1 equal to 17 T2 by 14. So in this equation, you can, instead of T1, you can put 17 T2 by 14 minus T2 equal to 1.5 hours. So by solving this, T2 can be taken out. So 17 by 14 minus 1 equal to 1.5 or 1.5 can be written as 3 by 2. So T2 into 17 minus 14 by 14 equal to 3 by 2. So T2 into 17 minus 14, 3. 3 by 14 equal to 3 by 2. So 3 get cancelled. So T2 equal to 14 by 2. Answer will be 7. So T2 will be 7 hours. T2 will be 7 hours. Understood? Here the question is, the first train started by 2 o'clock. The second train started by 3:30 p.m. First train is moving at a velocity of 70 km per hour. The second train is moving at a velocity of 85 km per hour. Even though they are started at different timings, since the velocity of the late train is more, at some point they will meet each other. So the distance traveled by both of them will be equal. That we have to consider. So first distance is equal to velocity of first train into the time taken by the first train. The second distance, the distance is the same distance traveled by the second train, that is velocity of second train V2 into time taken by T2. So you have to put both, since both distance are equal. So you have to equate both the case. So 70 into T1 equal to 85 into T2. So you'll be getting 70 into T1 equal to 85 into T2. That means finally you are getting a relation between T1 and T2. So T1 equal to 17 T2 by 14. So at some point they will meet each other. So what is the time difference between both? So you have to consider the time difference, because 2 o'clock and 3:30 p.m. means there is a gap of 1.5 hours. So the time taken by T1 and that both the trains, the difference can be taken as T1 minus T2 equal to 1.5. So in this case, T1 can be put. So in this equation, instead of T1, put 17 T2 by 14. So by solving that equation, you will be getting finally T2 equal to 7 hours. If T2 equal to 7 hours, what is T1? 7 plus 1.5. It will be 8.5 hours. So time taken by first train is 8.5 hours. The time taken by second train is 8 hours. The question is at what time the trains will meet. For example, the first train is started at 2 o'clock, 2 p.m. So the first train travels a distance of the same distance with a time of 8.5 hours. So if you add 8 hours with 2 p.m., you will be getting 10.5 or 10.5, or you can say the 8 hours means 8 hours and 30 minutes. So 8 hours and 30 minutes, if you are adding together, you will get 10:30 p.m. So answer will be 10:30 p.m. At 10:30 p.m., even though they started at 2 o'clock and 3:30 p.m., at night 10:30 p.m., both train will meet each other. So answer will be C, 10:30 p.m. Understood? Okay. A train 100-meter long. A train 100-meter long completely crosses a 300-meter long bridge. One bridge is here. The length of the bridge is 300 meter. A train 100-meter long completely crosses a 300-meter long bridge in 45 seconds. What is the speed of the train? So what is the total distance? It should be sum of the train plus bridge. So it should be 400. So distance traveled is 400. Time it is given as 45 seconds. So 400 meter and 45 seconds. So speed is 400 meter by 45 seconds. So 8 into 5, 40. 9 into 5, 45. So 80 by 9 meter per second. That is the speed of the train. But the answer given in kilometer per hour. So meter per second, how can we convert into kilometer per hour? 18 by 5. So 1 into 5, 1 into 5, 6. So, 1 into 9, 2 into 9. So 2 into 16. Answer will be 32 kilometer per hour. So answer is 32 kilometer per hour. Answer is right. So if a post is given, consider only the length of the train. If a post and a platform, or if a post or a bridge is given, you have to add, in order to get the distance, you have to add both the length of the train and the length of the bridge. Okay. The next question we will see. Two trains, 121 meter. One train is 121 meter and the other train is 165 meter. The other train is 165 meter. In length are running in opposite direction. Running in opposite direction. He is going like this and he is going in the opposite direction. First, the speed of first train is 80 kilometer per hour. The speed of the second train is 64 kilometer per hour. In what time they will completely clear off each other from the moment they meet? So what is the total distance you should cover? 121 plus 165. Then only we can say that it will completely clear off ho gaya. So the total distance is equal to sum of the distance 121 plus 165. 51 plus 6, 8, 2. If the trains are moving in opposite direction, they are moving away from each other in a very quick manner. That means the speed is more. So relative speed should be V1 plus V2. So one is at 80 kilometer per hour. This is actually meter. Okay. Kilometer per hour. And the other is 64 kilometer per hour. So total is 4 plus 8 plus 16. So 8 plus 6, 144. 144 kilometer per hour. So what is the time? Distance by speed. So 286 meter by 144 kilometer per hour. So you have to consider the conversion, because meter and kilometer you cannot do. Here the option given is in second. That means we have to convert into meter per second. So kilometer per hour can be converted into meter per second. 286 meter divided by 144 into 5 by 80 meter per second. So meter cut. So second will be coming to top. So 286 into 18 by 144 into 5 seconds. Okay. We have to cut 9 into 2, 7 into 2, 2 into 2. This is actually 8 into 9. This is 1 into 9. 9 into 8 is 72. So this cut. Then 286 divided by 8 into 5. 286 by 40. That means seconds. So 1 into 2, 4 into 2, 3 into 2, 20 into 2. 143 by 20. We will do 143 by 20. 7. Remaining will be 3.
3 by 10.
Either answer is not given in fraction, in decimal. So you have to do it again. 1 into 20. So 10. Again 0, 5. So answer will be 7.15 seconds. So based on the choice you have to do. In some question they will be providing in mixed fraction. In some question it will be in decimal also. Next question. Question number 11. The speed of a boat in still water is 18 kilometer per hour. Speed of a boat in still water. Not flowing. Like lake. If you are keeping in a lake, the boat speed is 18 kilometer per hour. Speed of boat in still water. Still water is 18 kilometer per hour. And the rate of current is 14 kilometer per hour. What is rate of current means? The flow of the river. Flow of the speed of the river. Or speed of the stream. As you can like that. Speed of stream. Stream means it can be upstream and it can be downstream. The speed of stream is actually 14 kilometer per hour. Find the distance traveled in downstream in 15 minutes. Find the distance traveled in 15 minutes. If the boat and river are flowing in the same direction, the speed will be, we have to add. Here boat is also moving in the same direction. So speed should be, we have to add V1 plus V2. So it will be 18 plus 14. So 32 kilometer per hour.
Correct, minus 7.
That is relative speed. Here we have to consider the flow of movement of boat in a water. Here actually the river flow is helping the boat to move. So one extra help is given by the water. Therefore, it can move little fast. If you are swimming in a water, if you are flowing against, our speed will be less. If you are flowing along with the water flow, we can move little fast. So our speed will be increased. That concept you have to use. So speed is equal to V1 plus V2. So 18 plus 14, 32 kilometer per hour. Then how much distance? Distance is equal to speed into time. Speed is 32 kilometer per hour. Time is 15 minutes. So what you have to do? 32 in, here the answer is given in kilometer. So you have to convert minute into hour. Minute into hour. So 32 kilometer per hour into 15 minutes. Actually 1 minute is equal, sorry, 1 hour equal to 60 minutes. So 1 minute is equivalent to 1 by 60 hour. 1 hour is equal to 60 minutes. So 1 minute means 1 by 60 hour. So 1 minute is equal to 1 by 60 hours. So 50 minutes means you have to multiply with 1 by 60. So it will be hour. So this hour and this hour will get cancelled. So 15 into 1 by 60 means 1 into 15 and 4 into 15. So 32 by 4. 1 into 4 and 8 into 4. So answer will be 8 kilometer. So that will relative velocity and this relative velocity you should not mix, because here if a boat is moving downstream, the river is actually helping him to flow. So his speed is more because he can travel with a greater speed because extra force is given by the river flow. If we are taking in the upstream, you have to minus because river is in the opposite direction. Even though we are going with a higher velocity, we will not be able to move effectively. We will not be able to move in the same velocity. So we have to consider the minus. So if we want to go upward, upstream, the velocity of the boat should be higher. If the velocity of the water is more and the velocity of boat is less, means we will not be able to move upward. If we want to move upward, the velocity of boat should be higher and velocity of the water should be less. Then only we will be able to move a little to the upside. Then next question. Question number 12. A boat covers 24 kilometer upstream and 36 kilometer downstream in 6 hours. A boat covers 24 kilometer upstream. A boat covers 24 kilometer upstream and 36 kilometer downstream in 6 hours. If it covers 36 kilometer upstream and 24 kilometer downstream in 6.5 hours, find the velocity of the current in both the directions.
Both upstream.
Boat upstream. First boat covers 24 kilometer up, then coming by to 36 kilometer down in total 6 hours.
The total distance of
Not the total distance. We have to calculate the velocity of the water flow. Boat speed is constant because we are controlling that. So first of all, the boat is going up 24. That means, suppose here, I am here. The boat is here, boat. Now he is going to a distance of 24 kilometer. So this reached this point. Now he is coming back 36 kilometers. So his initial point will cover.
minus 20.
If this is 36 kilometer. 36 kilometer. So boat is moving from here to here 24 kilometer. So what will be the velocity?
We have to find the
Velocity of the water flow. If the velocity of boat is VB, velocity of water is VW. In upstream, we have to do minus. So velocity in upstream will be V water minus V water. Velocity in downstream will be V water plus V water. So this, first of all, boat is moving 24 up and then 36 down. The total time taken is 6 hours. Then the next condition given is, for example, the time taken T1, T2, T1 plus T2. The next case, if the boat is here, now he is going 36 kilometer up, then 24 kilometer down. 36 up and 24 down, 6.5 hours. Here, 6.5 hours it will take. Here, 6 hours it will take. So you have to calculate the velocity of the current in both directions. Velocity of current in both directions, upstream and downstream. Okay. So you can consider like this. Time is equal to distance by velocity or speed. Time is equal to distance by speed. So this time should be divided into two parts, T1 and T2. So what is T1? So you can write like this. First case, total time taken is 6. Total time taken is 6. So 24 kilometer upstream. 24 kilometer upstream. So if you are putting VB minus VW as U and VB plus VW as V, the effective velocity in upstream is U. The effective velocity in downstream is V. So 24 by U. That is the time taken for to going to 24 kilometer up. Time taken to down means 36 by V. 36 by V plus 36 by V. So this is one equation. The second case, 36 kilometer upward. So upward means VB minus VW equal to U. Down means VB plus VW equal to V. So 36 kilometer upward means here the time taken is 6.5 hours. That is 36 divided by U plus 24 by V. So these are the two equations we got. So here actually you have to consider linear equation in two variable, that concept. For example, if I am putting 1 by U equal to X and 1 by V equal to Y, 1 by U equal to X and 1 by V equal to Y. So I can write this equation equal to 6 is equal to 24X plus 36Y and 6.5 is equal to 36X plus 24. When you are seeing 1 by U and 1 by V, you are will be little confused. So if you are putting 1 by U as X and 1 by V, Y, this is normal linear equation in two variable. So what we have to do? So 36, 24. Normal linear equation two variable you have to use. Okay. 6.5. Simply add. You simply add, you will get 24 into. Oh, okay. Otherwise, we will do like this also. We'll try. We will. If this is first equation, this is second equation. Instead of putting the substitution, x plus y. If you are adding this two, what you will get? If you are adding this first and second equation, 6 plus 6.5 is 12.5 equal to 24x plus 24y. 36x plus 34y. So 24x plus y and 36 x plus y. 12.5 equal to 24 into x plus y and 36 into x plus y. So here that is also possible, but it may go to little lengthy. Okay, so 36 plus 24, it will be 60 into x plus y. So 60 into x plus y. So 12.5 x plus y equal to 12.5 by 60. 12.5 by 60. 6 plus 6.5, 12.5 equal to 60 into x plus y. Okay. Then if you are doing minus, 1 minus, this is you got from y 1 plus 2. If you are putting 1 minus 2 or 2 minus 1, 2 minus 1, you will get 6.5 minus 6 matlab 0.5. 0.5 equal to 36 minus 24. Oh, you can put like this, 36 into x minus y. 36 into x minus y and 24 into y minus x. 36 into x minus y and 24 into y minus x. So 0.5 is equal to 36 into x minus y plus, or you can put minus 24 into x minus y. If you are taking minus outside, you will be getting like this. So 36 x minus y minus 24 x minus y. 8 into 8, not 8, 12, na? 12 x minus y equal to 0.5. So you are getting x minus y equal to 0.5 by 12. So you are getting two equations. X plus y equal to 12.5 divided by 60 and x minus y equal to 0.5 by 12. So if you are adding these two, you will get 2x is equal to 12.5 by 60 plus 0.5 by 12. So if you are multiplying with 5, so you will be getting 12.5 plus 2.5 divided by 60. 12.5 by 2.5, 15. 15 by 60. 1, 4. So 2x is equal to 1 by 4. X is equal to 1 by 8. X is actually 1 by u. So 1 by 8. So u equal to 8. So this is the effective velocity in x. What is u? U is actually Vb plus Vb minus Vw. Effective velocity in upward direction. U is equal to Vb minus Vw. So this is the 8 kilometer per hour will be the effective velocity of the stream in upward direction. Then if we do minus, you can put here also x plus y equal to 12.5 by 60. Na? So x plus y equal to 12.5 by 60. So x is 1 by 8. X is 1 by 8. So 1 by 8 plus y equal to 12.5 by 60. So y equal to 12.5 by 60 minus 1 by 8. So if you solve this one, 60, 80. Mm, So 12.5 into 2 minus 1 into 15 divided by 120, because the LCM is 120. So 12.5 into 2 is actually 25 minus 15 by 120. So y equal to 10 by 120. So 1 by 12. So y equal to actually 1 by v equal to 1 by 12. So v equal to 12. So answer you are getting u equal to 8 kilometer per hour. That is Vb minus Vw. V equal to 12 kilometer per hour. That is Vb plus Vw. They asked what is the effective velocity in the upstream and effective velocity in the downstream. So answer will be this one. So today we are going to wind up our today's section. Thank you.